All right, we're going to go ahead and start. It's right at 12 o'clock. It's June users group, and our topic today is going to be smart sensing. Got the real quick couple of intro slides, and we're going to turn over our guest speaker, who we'll introduce in a moment. Actually, I should have cleaned this up a little better. Today, of course, is June 20th. Really, what we had originally indicated for our next user group in July was a plant PAX topic around the middle of July. We had a quite a small change in plans there. Rockwell Marketing is going to come in town towards the end of July. They're actually July 31st for New Orleans with a visualization roadshow, they're calling it, so the visualization update. So we're going to kind of make that our users group. It'll be a lunchtime seminar, and we'll live stream it as well, just like we do our user groups, or you can come in live into our Harahan office, and that'll be a it's going to be about a 2-hour session, but it's going to be a complete update on all the visualization products from Rockwell. So panel views, VersaView computers, thin clients, all that stuff. And then after that, in August, we're back to a power topic, which will be introduction to VFDs, which our very own Rob McGlynn will present for us. He will come out of the shadows and speak for us finally. Also in the works, the Rockwell Automation on Tour is happening now. And if you're here in the room live with us today, we have all the demo cases set up. We'll have that going on the rest of this week, all next week, and then even the week after that, 4th of July week. So we'll have these cases set up for a couple weeks. So reach out to us if you want to come in and go through some workshops. And then still without dates defined yet, but we have the Drives headquarters coming at the end of July as well. And that is a bit of an overlap with the visualization roadshow at the same time, but the Drives headquarters will also be in town that week. And that'll be a very similar event with hands-on with the drives, demo cases and hands-on experience with drives. And that was really it for introductions, introductory slides. We'll let our guest speaker do the rest of the talking today. We're pleased to actually introduce not only here with us live today, but it's actually his first week on the official job as well. So we breaking you in quick. Sir Rob Banerjee, or Rob as he's better known as. So components area manager with Rockwell Automation. He's going to talk about, we'll introduce himself first and then talk about smart sensing. And Rob, I'm going to put your presentation up.
Sure. Hi, everyone. My name is Saurabh Banerjee. As Wayne mentioned, I just took over the components area manager. Today's actually my 3rd day. I just moved from Chelmsford, Massachusetts to Houston. I'm based out of Houston, and I'll be covering Texas as well as the New Orleans region, the Louisiana region completely. Just a little bit about me. I've been with Rockwell for 5 years now. I started off as a field service engineer, and then been involved in different projects, Studio 5000, PLC, L8Z releases, as well as other motion groups. Lately, before I accepted this role, I was with the sensing group. So my main role was condition sensing, RFID, as well as anything to do with smart sensing, designing that. So I was with the product management group over there. And then after 3 years of that, I wanted to try my hands in sales. Wanted to go out in the field again. I had this wonderful opportunity, and from Monday was my first day here. So I know we have only 1 hour. I'll try to go through. Please feel free to ask as many questions as you can. This topic, as we're also learning more about smart sensing as we are developing it. It's a revolution that's happening. So today, what I'm going to do is try to introduce the topic of smart sensing, as well as tell you where Rockwell's plan is for the future and what are our current existing portfolio, and how having smart sensing is actually better, and how it's actually helping customers drive productivity. So, the entire world right now is going through what we call as, the fifth industrial revolution, with the industrial Internet of Things that's happening. Everything that's out there in the field. It's not about the machines anymore. It's not about how big your factories are, but it's about the final product. So end users, OEMs, everybody's concentrating on making the product better, as well as with more products coming out, there needs to be a lot more flexibility. That means that now, there's been a world where there was mass production, right? So, going back to the world of Ford, when the Ford says, yeah, you can order any color of car that you want as long as it's black, right? Right now, you can choose the color of your car as and when it's being built. So that's the world that we're living in. It's mass customization. With that having said, the flexibility is essential for all of us, from the OEM side as well as on the end user side. And with this flexibility often comes demands for much data that's coming out all the way from the user or the customers all the way down to the person that's actually operating that machines. So the entire market is changing, where your increased focus on the product, you need for a flexible system, as well as analytics. So right now we're living in a world of data, but what we're doing with the data is what we're getting out of the data is more important than how much data that we are getting out. So that's where we're developing a lot of the analytics solutions that are needed from any manufacturing world. And that's how the market is totally changing, where there's huge pressure on the OEE. Every day, customer is trying to innovate ways to be more productive, as well as driving that OEE. I'm sure all of you have heard about the connected enterprise story with Rockwell. So the connected enterprise is an overarching enterprise level software that connects all the way from the device level all the way up to your enterprise level. Where sensors sits, or I would just elaborate this, not just sensors, but on devices. Sorry, go back, is right where it's down at the level of the devices, right? So the devices are at your plant level. To enable and achieve that goal of that connected enterprises, not only do you need smarter software systems, not only do you need smarter PLCs, but also you need smarter devices, because the devices are the ones that are actually taking the data out from the physical systems that are out there and feeding it onto the higher level architecture. And then the software behind those architectures are actually making sense of the data. So that is the critical need for having smart devices, be it a sensor, be it a motor, be it any kind of manufacturing devices that are actually installed at the manufacturing floor. So when you talk about customers, there are definitely two big segments, right? So there's the end user customers and there's the OEMs. Now, when we talk about smart manufacturing, the end users, they are focusing more on a couple of these drivers. So faster time to market. They have a lot of assets that have already been installed. They have new assets that are being installed as well. So they want to optimize the utilization of those assets, and that's crucial. And their major goals to all these drivers are to exceed their productivity as well as exceeding their efficiency goals. As an OEM, they are serving the purpose of making the equipments and the machines smarter, so that the end user can achieve smarter manufacturing. So their major drivers are more on the flexibility side, how faster that they can build that machines, how they can integrate that machine in a customer environment, as well as they have to keep in mind about the cost, not only the cost of the machine, but to design that machine, as well as maintain that machine. So once that machine is out there in the customer floor, how can they maintain that machine, and how can they provide that maintenance service to the customer? So that's kind of the biggest drivers that are currently addressing or being seen in the marketplace by the end user as well as the OEMs. So with that having said, this partnership, so this interaction between the end user and the OEMs are changing. So in the past, OEMs operated separately, end users operated separately, and basically OEMs and end user was not very much involved in actually designing the OEM machines. That vendor supply relationship is changing a lot, where now it's becoming more of a partnership, right? Where the end user has a lot more to say on what exactly they want out of that machine. They have a lot more to say on what the specification that goes on the machine, what kind of maintenance they want on the machine, etc. So that relationship is now slowly changing into more of a partnership, where now the OEMs have a lot more constraints from the end user side, and they're trying to make the best out of, with those constraints in place, they're trying to make the best of those machines. One of the other factor is there are two kinds of machines, right? There are new machines and there are machines that are already deployed. The lifetime of these machines can be anywhere between 10 to 20 years. So when we talk about changing environment, new businesses, IIoT, connected enterprise, many of the times it is geared towards the new machines. However, from an end user standpoint, they already have a huge install base of these older machines. And so what they want to focus on, going back to their goal of increasing that productivity, is to increase that lifetime of that older systems. So OEMs are now being in that constraint of how do we make these older machines, some of them are 20 years older, how do we make them faster at without changing much of the design, without changing much of the wiring? So that's another big challenge. The other part of it, as I mentioned, the business of maintenance, right? OEMs are now being requested to actually maintain the entire life cycle of the machine. But what else can you do in the maintenance? And we are seeing a slow shift. So when you talk about maintenance, there are 4 layers of maintenance, right? The one is just identifying what the problem is. The second one is more of diagnostic. That tells you how the things have happened. The third layer is actually predictive maintenance. So what predictive maintenance does is it collects the data and tells you what is going to happen based on historical facts and figures about the parameters that's working. But the market is slowly moving on. Okay, so now I know that in a week or in 2 weeks, my machine's going to fail. But that's not enough to know that. What am I going to do in order to prevent that failure? And what are the things that either a maintenance personnel has to do or the machine has to do? So that's where it goes to a prescriptive maintenance. So it's just not saying what's going to happen, but it's also going to say you what you need to do as a customer in order to prevent that from happening, so that you don't forget that going forward. So knowing about these issues when it happens, and also what to do about them is becoming critical. And that's where the smart devices, the smart sensors are playing that role, where they can feed you that data, they can help you capture that data, but also help you diagnose, predict, as well as prescribe you the way that you can prevent those failures from happening. So that's the environment that it's evolving. This slide basically, there are a couple of challenges that today's machine builders are facing. This is just some of them where, as I said, they are working with a lot of constraints right now from end users. So there is a challenge in order to meet that expectations based on performance, but also based on differentiation, right? So every day we hear the word of continuous improvement and innovation. With everybody in today's world, trying to be one step ahead, there is that challenge to continuously differentiate yourself based on from your competitors. And also, the other part of it is preventing the problem. So a lot of times the OEMs are called when a machine fails, but that time it's a fire drill, right? So when I was a field service engineer, most of the times I got a call was like 4 a.m. in the morning. You got to go out there and you got to, the machine is down, so you got to bring it up to speed. So how do we prevent those fire drill activities so that more power is given to the end user side, as well as to the OEM maintenance, where they can do more remote maintenance as well as get those data out? So that's some of the other challenges, right? From an end user side, again, performance is key. because there's huge demand on customization, making sure that the customized products does not involve lead times. We all know what's going on with Tesla, right? So Tesla has so much of customization that's required. It's very difficult to meet and keep up with that demand. So that flexible manufacturing, but in order to do that flexible manufacturing, one thing that they are trying not to do is to decrease that performance level, because that's the key over here. And it's very similar. What the OEMs are also doing is the end user wants to know what is wrong, when it's happening, and where is it happening. And they don't want to spend more than 10, 15 minutes to actually figure out, okay, what is actually wrong. And then the third part of it is actually how you prevent it. So that's just a bit of what the market right now is, and how smart sensing is enabling this. So when you look at machine lifecycle, I've broken it down into a couple of key areas, right? So in the life cycle of a machine, there is the design phase, there's an implementation phase, there's an operation phase, the maintenance phase, and then there's the improvement phase, right? And this life cycle might be 10 years to 20 years, depending on the complexity of the machine itself. So when you talk about the smart sensing, the design and the implement phase is when you start seeing some value. The value is less, but you see the value of reducing the time to actually design your system, making sure that the systems are up and running. It saves you time to actually implement that. But where the real improvement and the real value comes in is when the machine is up and running. You see how you optimize that machine. You see how the machines, you save money in making sure that the machine is running in the optimal speed, making sure the parameters are not being messed around. Quite recently, we saw that, again, going back to Tesla, someone had actually changed something in the parameters of the Tesla plant. But capturing that when and where it happens immediately is very key. So smart sensing allows you to do that. So anytime there is a change of state, or anytime there is a deviation from the change of state or the change of event gets logged in, you can actually monitor it, you can store it, as well as you can trend it, and then that allows you to do more predictable maintenance. So on the maintenance side of it, we have, you shut down the plant and you actually maintain the plant, but here it actually tells you when it actually needs to be done, so that you don't, instead of regular shutdowns, you can actually plan your shutdowns if needed, or when we go into that prescriptive side, it will actually alter the parameters on its own so that the machine keeps running optimized. And like I said, the focus is on continuous improvement. So when you have a smart system, you open up the doors on making sure that if the way the machine is running now, you can optimize the machine with later parameters, or if there are any change or if any future firmwares. So that way you can keep ahead of your competitors and you can keep improving. So as you can see, the value of deploying a smart sensing system just goes increasing exponentially as and when the machine lifecycle keeps increasing. So if you face with the situation, or if you face with any question or doubt on whether you ever need a smart system, just keep this in mind, that the value or the return on investment comes in as and when the machine is running. So I've been talking a lot about smart devices, smart manufacturing. So what exactly does smart device? What makes a device smart? There are 4 legs, you can call it, to what actually makes a device smarter. Number one, and first and foremost, is the device and the information. So traditionally, when talking about sensors, is always the eyes and ears of your factory, right? But traditionally, if you talk about a photoelectric sensor, all it did was on and off. So it's just a change of state. But it has so much data that it can actually capture that was being wasted. So what we did was making sure those devices can actually capture that information as well as diagnostic, but also the second part of it is enabling technologies. So capturing the devices at the machine plant floor is not enough. So making sure that these machines are not in a siloed, but being able to communicate with higher level architecture system is very key. So all of these devices and information that was captured, making sure that there are some means of communication so that it goes to your PLC level or to your analytics level, that is key. So making sure your devices have built into that platform. Number 3 is customer experience. So a lot of time there are smart machines, but the thing is there are also complex machines. So one of the things that Rockwell is trying to do is design smarter devices, but also taking out the learning curve from the end user or the OEM side. So making sure that it's seamless, making sure that it works with all layers of PLCs and softwares, and making sure there is not much of learning that needs to be done. So it's kind of like a plug and play feature. And also to try to standardize the look and feel of each and every devices that we have on the smart layer and how it interacts with other layers of systems. The other part of it is the analytics, right? As I mentioned, we are living in the world of data, but that data is useless if we don't have the proper analytics to actually make sense of the data. So making sure that the sensors itself, whatever the data that it sends higher up, they are designed in a way that the analytics software can actually extract the data out. So Rockwell, as you know, we partner with Microsoft for different analytics platform, but making sure that they are for all of our analytics. So for example, FactoryTalk Analytics for devices, FactoryTalk Analytics for machine, making sure that our devices are programmed in that way, in such a way that it's easy to extract those information. So those are the 4 layers that, the smart devices, that makes a device smart. So again, back in like 4 or 5 years back, Rockwell started this strategy where they wanted to make all their devices smarter. So there are 3 things that we're focused on. Number 1 is motor control. Number 2 is sensing, and number 3 is safety. And this is like a slide that I took from our brochure that we created last year. But the main factor of it is that all this is creating an ecosystem. So if you have devices that are non-safety, if you have devices that are doing smart motor control, and if you have devices that are safety devices, they all have the same look and feel, as well as they have the same way that you interact with them. And they're all able to collect the data. They all use the same common software. They use the same analytics tool, as well as they line up with all the smart machine analytics platform that we have. Today, we'll focus more on the smart sensing, but this is an overall view where Rockwell is heading to. So as I mentioned, device information and diagnostics. This is the first leg of a smart devices, right? So the devices can, the information can be generated anywhere throughout that plant level, right? So there's a plant level, there's an enterprise level. So through that level, the best place to actually get the information is where it is occurring. And the best machines or the best devices are the sensors that we have are the ones that are actually collecting those information. So it's very important to collect that information, and our sensors are capable of collecting that information and the diagnostic information, and then sending it up to the higher architecture level. So some of the information that our devices capture based on the machine operation, number 1, it gives you, if there are some alarms or warning signals. So for example, one of our photoelectric, so what it does is if there is dust that builds up on the lens of the photoelectric, it will immediately signal that, hey, dust is being built up. So there's a low margin alarm. So I do not have enough margin to actually see the object in front of me. So somebody come and clear it for me. Those are very small things, but also like diagnostic based on power cycle, diagnostic based on usage, diagnostic based on if the object is coming too close to a sensor that might actually damage the sensor. These can slowly relate. If this is not being monitored, then what happens is there might be downtime, because if there's a plant that breaks down because an object goes and hits a sensor, then it might actually clog that entire line. So all these are being monitored, and you can actually monitor it and store it back into your PLC, so you can change it accordingly. The other part of it is, again, as I mentioned, is a customer experience. The customer experience has to be that it's all in one software environment. It's easy to use, so that you don't have to spend much time in programming and user manuals and learning about that product itself. We have made a decision that any new sensor that's going to come out, it's only going to be smart sensors. So and we are going to put in some enabling technologies in it. And these smart devices, for sensing especially, it's not going to cost. It's going to cost the same as a non-smart sensing was. So it's just that we want to keep the same cost structure. The same price structure, but making sure that all the devices that are coming out are all smart devices. This is the second part, is the enabling technologies, right? So with the enabling technologies, you might have heard about IOLink, you might have heard about Ethernet IP. Now, IOLink is one of the enabling technologies that actually collects all the data from the sensing and puts it back up in the higher architecture level. So with IOLink, so imagine now you're talking about a photoelectric sensor, right? The photoelectric sensor, you can't put an Ethernet IP on it. Number one, there's space constraint on it. Number two, it might cost more for the sensor itself. And number three, imagine a plant where you have 500 sensors and now you're managing 500 different Ethernet nodes. So what we have done is, instead of doing that, IOLink is an open standard technology. It's been around for 18 years right now. Slowly, we are trying to implement and get on board with IOLink. The IOLink basically is a point-to-point communication where it's the same sensor. What it does is, you have an IOLink master. It converts the data from the sensor to a digital converter, and it allows you to capture the data to that master and then sends it all the way via Ethernet IP to the higher level architecture of PLCs. And what we have done is, in order to make that happen, as well as to make it much more simpler, we've also created add-on profiles in Studio 5000 that didn't exist before for sensing. So we have add-on profile for the masters, as well as we have kind of a low-level add-on profile for the sensor itself. And each of these add-on profiles are unique to every sensor catalog, which is what we call as the IODDs. And down the presentation, we will go through the IODDs as well. Yeah, question.
Sometimes it's helpful for our customers to talk a little bit about IOLink. A good analogy is IOLink is similar to HART in the instrumentation world. Where you're using the wiring for the device to also be the transport mechanism for the communications in that device.
Correct. Yeah, that's a good analogy. The only thing, there are some constraints as compared to HART. Sure. With HART, there's much longer distance. With IOLink, there are some challenges, but you're right. It's kind of like a transportation.
You're taking your discrete signals that you already have, and
correct,
you're embedding a digital on top of standard wiring.
Yeah, and where it helps is also with analog devices. So in the past, with analog devices, you had to worry about noise issues, you had to worry about conversion, you had to buy analog cards. With IOLink, it's all in the same, because it's a digital signal. So right now, all you need is one IOLink that can do inputs, outputs, as well as analog devices to it. That's a good comparison. Thank you. This is a quick overview of some of the enabling technologies or smart sensing that we have. As you can see here, it's divided into two. One is Ethernet. So on the right-hand side, you have all Ethernet solutions. So all our sensing that has Ethernet inbuilt in it. These are, of course, a bit more expensive than the non-Ethernet solutions. So the non-Ethernet solutions are where all the IOLinks are being focused on. Where these sensors are, they're much more less expensive sensors. Like they're the proxes, the photos, your pressure sensors, and all of this is then connected via Ethernet IP, and all the way goes up to your design environment, which is your Studio 5000 via your PLC. So what it does is it's a much easier and quicker, as well as less expensive way to get that data out. like you're mentioning, it's that transport mechanism. But we also have a portfolio of sensors, which is RFID. There is a code reader that's on the way, as well as encoders that have inbuilt Ethernet IP communications on it. So now you can have that node all the way up to your design software, and you get the data much faster.
So Rob,
Yes.
Go back to that slide.
Yeah.
So they have the connected enterprise bringing industry 4.0 to life. What's can you
That's a good
elaborate
question.
on the 4.0?
So the question was for everyone on the line is what is that 4.0? So 4.0 is a term. It's a European term. It's the same as our connected enterprise. So 4.0 was designed as a standard by the German government, as well as a part of other European governments, in order to bring all these data out to that manufacturing layer. So it's the same as the connected enterprise, where you're connecting all the way from the enterprise to the device level. So but Industry 4.0 is, as I said, it's the other revolution, where we are now living in that world of data. So it's how you collect that data, and then how you communicate it. And here in the North America, Rockwell is calling it as a connected enterprise, but it's on the same concepts as the European manufacturer. The difference is with Industry 4.0, since it's very driven by the German government, it standardizes on Profinet. And it basically says in the spec that you got to use Profinet. With connected enterprises, it's more on open protocols. So it's on Ethernet IP, it's on IOLink. So it's much open in that way, that many other devices can be programmed and built in that way. We touched on this topic a bit, but so if anyone wants to know what IOLink is, it's a standard protocol. It's an open protocol that's been developed in Europe. It's not a field bus. It's a point-to-point communication. So every sensor, every channel is dedicated to its own sensor. So if you already program your channel to a particular sensor, and then you have a different sensor, it will not work. You've got to have the right catalog. It's the good thing about it is a forward-backward compatibility. So if you have a sensor that today IOLink has different versions. So it's on the firmware versions. So if you have a 1.0 version and you have your sensor as 1.1 and you have your master as 1.0, you can always do a fallback of it. Some companies support it. It's not mandatory to support it, but slowly we can expect to see more and more of these versions coming out as the sensors are getting smarter, as well as more capabilities being built to these sensors. The good part of it is that, say today you have a photoelectric sensor, and tomorrow we upgrade a photoelectric sensor, the same hardware, but the firmware is different. Then you don't have to actually buy a new sensor, but you can actually just update the sensor on the firmware side. IOLink uses the same cables, so there's no change. It's you don't need any special cables for it. It's an M12 3-pin connector, or 4-pin. It only uses the 3 pins, and you can actually. So the good part about IOLink is all of our sensors are now any new sensors, and most of our sensors are now on IOLink. So it's upon you as a customer to actually choose whether to actually take advantage of the IOLink or not. The sensor is going to act as a standard sensor no matter what. But if you want to use it as IOLink, it has the chip built into it. So if you have the IOLink master and you have the IODD file, it helps you to enable that entire chapter of IOLink. So if you say in a line you have 100 sensors and you only need 40 sensors to work on IOLink and the remaining 60 non-IOLink, then it's the same catalog number, it's the same price. It's how the customer wants to choose it. So that flexibility is also there. So it's a standard sensor with IOLink chip inbuilt into it. And the other part of it is each of these sensors have data that's being that it produces. So all these data are configuration data or just diagnostic data is accessible via the IO data configuration up to your PLC level. So this is just the architecture. as you can see, as I mentioned, there are 3 layers in IOLink. I'm not sure, can they see this? Okay. Yeah, so I have a demo box set up. It's actually Bill's demo box. So over there we have a point IO solution of IOLink. So this is the IOLink card, which is on the point IO solution, and then we also have the oh, hey Wayne.
Temporary technical difficulty caused by the moderator.
Is there another camera here? Just 2 cameras.
Let's go back to the way we had it. Sorry about that.
Yeah, no problem.
I gotta make
Oh, that's fine. I mean, we can just go back to the presentation. Oh, I have to do it?
I got you. Sorry about that.
Okay.
We'll have to figure that one out.
All right, so the architecture is very simple. So you have the PLCs, and then the PLC have their Ethernet cards, or you connect that Ethernet card to a static switch. So that's your point of access. With the IOLink, there are 3 parts of it. One is the IOLink sensors itself. That's your IOLink devices. So all of our sensors, or it could be also an actuator. So it could be an output device as well. So you need a device that has IOLink inbuilt into it. You need an IOLink card. So what is an IOLink card? It's just like a gateway. So just like any point IO cards, there is an IOLink card. The catalog number is actually over there. It's a 17344 IOL for the point IO solution, and then there is the 8 IOL, which is more on the armor block solution. So, and then you need an IODD. The IODD is nothing but an EDS file and an extended EDS file that goes into Studio 5000 programming. So the difference between these 2 architecture, as you can see, on the 4 IOL, which is on the point IO solution, it's more, it can only connect up to 4 sensors, but you can expand the point IO to 64 blocks. So you can actually have multiple of those cards, and each of those cards can have 4 sensors to it. With the armor block solution, it is on Ethernet IP. So Ethernet IP is inbuilt into it. So you can connect your Ethernet cable directly, as well as it has 4 ports, but you can use a splitter. So I've put a splitter over there. You can use a splitter to actually split each of the ports into 2 channels. So you can actually connect up to 8 sensors for the armor block solution. The other difference is that with the 8 IOL, since it's on Ethernet IP, you can also do timestamping. So anytime you have change of state events occurring, or you have a change of parameter or any events occurring, you can actually trend and timestamp that data. That's not possible with the 4 IOL because the point IO does not support that fast timestamping platform. It's pretty slow. But those are the main differences. And please notice that the sensors that are connected, you have a photo sensor, you have a color sensor. Those are your standard sensors. You also have prox sensors. That's also a standard input device. But you also have an actuator valve manifold. So it's an output device. So we're using the same card. You can actually connect an input device as well as an output device, as well as you can also connect an analog sensor. So I have a pressure sensor that's up there. So it's an 836p pressure sensor. That's an analog sensor. So previously, in order to connect that, you need to buy an analog card. And the analog card is usually a bit more expensive. It needs special wiring. You need to account for noise. You have to do a lot of changes on the engineering, on the design software side. With this, you don't need all that. You just need one card, and you can program it to function for the analog sensor as well.
Rob, before
sir.
you get off the slide, I just want to, for the audience, everything on here is Rockwell Automation products, except for the actuator valve manifolds. Those are Rockwell has an Encompass Partners. One of them is like Parker Hannafin that actually has these, and we as the rentals company would be glad to help with providing solutions for that into this too. And they also, with the Encompass partner, I think Robbie will go into a little bit later, but they actually pull up AOPs with them too.
Correct. That's absolutely right. With the Encompass partner program, we actually build their AOP and IODD file, so it will actually just look as if it's a seamless integration that none of our competitive solutions will have. So that's the design phase. Did I lock this up? It's on.
It's not the active.
Okay, cool. The other part that I was mentioning about is the customer experience, right? So all of this is integrated into an add-on profile. So there is an add-on profile for the IOLink Master itself. It's an all Studio 5000. So one quick point I forgot to mention, all the IOLink smart devices are for all of our control and compact logics V20 and above. So it only supports V20 and above, and going forward, all the softwares will support this. The devices itself have their own IODDs, and I'll go into that a bit later. But some of the premier integration that you don't get if it's a non-Rockwell sensor on a non-Rockwell master is you don't get the time stamping. You don't get the automatic device replacement. And I'll go into that a bit later, as well as you don't get the tags. As I said, each of these sensors have a lot amount of data. And if you don't know where the data is and where the data is stored or what the data does, you have to actually spend a huge amount of time in order to figure that out. What we have done is we have created specific names as well as structures. Also, some customers use these data onto some diagnostic informations onto the HMIs. So we have actually created faceplates. So each of these faceplates is in a zip folder, and it's published in the sample code library. So customers are free. It's free for the customers. They can download that zip folder, and it comes up with add-on instructions, and that can easily be implemented to any panel views. And as and when we are coming up with new sensors, we are going to come up with new faceplates as well, as Rockwell is trying to overhaul its entire faceplate design to make sure that everything looks alike. So we have just taken that same guidelines and created our own faceplates for now. And plus, the other part of it is if you have FactoryTalk Analytics for devices and the higher level architecture, you can actually use it for our sensors seamlessly, which is you cannot do that for the other sensors. So here's a quick view of the add-on profile. This is from the Studio 5000. So as you can see, if you open up Studio 5000, this is a standard AOP. This entire thing is the AOP of the IOLink Master. So when you pull up the IOLink Master, you have all these tabs on top, but you have an extra tab called the IOLink tab. So this is only present if the add-on card is an IOLink card. And once you pull that up, you get this view where it lists out all the different channels. Notice the mode on the channel. The channel can be programmed to function in an IOLink mode. It can be programmed to function in a normal standard digital in mode. It can be even programmed to do a digital output, or it can also be disabled. So if you don't want the channel, you can just disable the channel. And you can actually enter specific application name for the devices that you're connecting to each channel. So say you have two different tanks, one for a beer and one for Coca-Cola. You can actually have two different sensors, and you can actually name the sensor itself. So this allows you to identify the application. Also, On the left-hand side, as you can see, these are the different channels, and these are the sensors that are listed on these channels. The yellow triangle means that there is a key mismatch. So as I mentioned, each of these sensors has its own IODD inbuilt into it. So it's each sensor is unique based on its performance. So if you have a mismatch based on the sensor itself, then it will basically show you, hey, just check your channel. There is some communication fault. So make sure that it's the right catalog number, if it's the right series. On the right-hand side, there's a comparison between a generic sensor. So if it's a non-Rockwell sensor, as you can see, a distinct differentiation. So you only get the 3 tabs on top. It's a general connection module info, and you actually don't get anything out of it, right? So you have to map out how many inputs are there, what's the input instances, what's the size of the input. All those things you have to go back into whatever the size of the manual is. And if it's a complex sensor, then it just takes a lot of time. So we have taken care of all that. And that's the premier integration that we bring to the customer. This, as I already mentioned, you have named and formatted tags. So if you go into your IO folder, in your IO builder, you can see all the tags that are named. So this is for a 42EF. The 42EF gives you the gain of the sensor itself. It gives you margin alarm, gives you signal strength. All of that has been spelled out. As for a competitive or non-Rockwell sensor, as you can see, it just gives you the bits. And now you have to figure out each of those have 32 bits of data. So now you have to, it has 32 bytes of data. So now you have to figure out what every bit means. And now you have to map it. So some customers might say, well, I can look in the manual, I can use an AOI, I can, do all of that. But that AOI takes a lot of time. So you got to have a system integrator or a person who actually knows the PLC as well as the sensor, has that knowledge to actually make an AOI. The other part of it is AOIs are good, they're great tools, but they also consume a lot of processing time from the controller, because most of the time when you're developing an AOI, you're using class 3 message instruction. So every time you're using a message instruction, it basically bogs down your network. So these are some of the things that is good to keep in mind, especially if you have a large network of sensors. So instead of that, if you already have those data coming out as class 1 message instructions, class 1 connections, you have it part of your IO data structure where you can just pinpoint it and just look it up. This we touched on, as I mentioned, it gives you timestamp. Please note this timestamp is only available with the 8 IOL master only, and it's on Ethernet IP. So it timestamps whenever there is a fault occurring, it timestamps whenever it changes of state, or if somebody messes with the parameters or changes the parameter. Anytime that happens, it gives you exactly when and what happened, when it changed, as well as who changed. I mean, you can also have access controls to say who changed that. And you can monitor this from FactoryTalk View as well as from the panel view. This is one of the other premium integration of ADC. Now, Rockwell is big on ADC or ADR, automatic device replacement and automatic device configuration. So as we are going into new sensing, each of these sensors it becomes complex, and there are a lot of parameters, a lot of configuration. So say you have a pressure sensor, or say you have a line that's already configured. Say that line has been running for some time, and then the person who has configured it knows about the sensor is on vacation, and then the sensor breaks or falls. What are you going to do, right? It takes a lot of time to actually track down what exactly the sensor does, making sure the parameters are perfect, and now it all just builds up your downtime, right? So that costs a lot of money. What we are doing, if you're using our sensor and our master, and of course our PLC, we are actually, anytime you're configuring the sensor, we are storing that configuration all the way into your PLC. So that's kind of creating a backup. So anytime you have a sensor that faults or breaks or damages, you just have to get the new sensor, just plug it in, and the PLC will do a match. If it's the same exact key, it makes sure that it's the correct sensor. It will dump all the configuration parameters into the sensor. So that's your automatic device configuration, and that saves a lot of time. And in the last 2 years, there's a lot of customers just for this. They moved into smart sensing because they didn't want to change. They didn't want to spend time on adjusting potentiometers or the push buttons in order to make sure that the sensor is in the right parameters. So you can store all this. The other part that we have been getting requests is now we are storing from the sensor all the way to PLC. What happens if the master fails, right? So now we are making sure that the master also supports ADC. We kind of did not want to do that because even if the master fails, everything is backed up to your PLC. But there have been some requests from the customer. So the next generation master, you can actually do automatic device replacement from the PLC as well as from the master itself. So you have that both flexibility. But just a general advice, and this might be just me, is that always it's good to back it up to your PLC because it's always better. This is just a look on the faceplate. As you can see, this is again on sample code library for different sensors. As you can see, you can monitor this from the panel view. There's 3 tabs. There's a home tab that basically lets you configure all the parameters. There's a diagnostic tab that gives you all the detailed diagnostic that's built into the sensor. Some of the sensor monitors the temperature that it's being operating, how much hours it has been operating. All of those diagnostic and historical data you can view, as well as some application specific data that you can actually change the application name of the sensor itself. Plus, there is this very nice feature that I like a lot. It's called the locate sensor. So imagine you have like 30 sensors and one of the sensor fails. Usually right now, the process is you go in and you try to locate which sensor is failing. And that takes a lot of time, and not all the time it's accessible, right? So you might have to, switch off the line, or you might also have to, take your torch or whatever. With the locate button, if you press the locate sensor button, what it'll do is it'll send a command to the sensor and it will start blinking. So it's just a way of positioning and saying, hey, this is the sensor that needs to be replaced or cleaned. So that's another easier access way for the customer to locate that sensor and saves any other wastage of time. The signal strength is another built-in capability that we have in our sensor. This for photoelectric sensors as well as for our prox. So this is our new prox, which is the metal flat pack, as you can see on the top right corner. What happens in proximity application is, so you have a metal face on the proximity, but sometimes if the object comes too close to the metal and hits the metal face, it damages the metal face. From an user standpoint, you'll still see the sensor running because the communication is from the back end, but what the problem is, you won't know if the sensor is actually operating or not. So how do you prevent that? So we have this signal strength that's on there. What it does is it allows you to set your own threshold. So based on your application, you can set your tolerance limit. So every time the signal strength goes high, that is when the object comes closer to the sensor, you will get an alarm. And you can basically adjust it. So that's kind of a warning saying that, hey, make sure that you're adjusting your object because it's coming too close to the sensor. It might actually damage the sensor. And you can actually trend it. And over a period of time, you can actually predict when the next object is going to come. So that's the level of analytics that will help you out with that. This is just a walkthrough of the design environment. It's a Studio 5000, as I mentioned. This is the standard layer. You have the PC connected to your controller. It could be a compact logics controller, or it could be a control logics controller. This is showing with the IOLink master inbuilt Ethernet IP, and it's connected to a sensor. The AOP is the AOP of the master, and it shows you all the sensor that's connected. This is the registration of all the sensors that has been registered in your PLC. One complaint that we have been getting from the customer is, how do we, if it's a new sensor that's just launched, what do you do? How do you add that new sensor? So right now, the current method is you go to PCDC, which is Product Compatibility and Download Center, and you go in there, just like how you would download a new AOP, you just download a new IODD file. And once you download that IODD file to your computer, you can register that sensor. What we are doing now is this IODD files, what we are doing now in the next generation is we are actually embedding these IODDs in the sensor itself. So next time you have a new sensor, the IODD resides in the sensor, and then you can pull that data out from the sensor itself. so that eliminating that time to actually go to PCDC and all that. So once you select the sensor and the IODD file, this is the view of the IODD. This is for our temperature sensor. And as you can see, each of these sensor is unique. IODD has its own unique tabs, and it basically gives you data about the sensor itself, gives you data about the vendor, as well as it gives you a parameter tab where you can change the parameters, and of course the diagnostics. And the advantage of that is when you have that IODD, you automatically get all of those data in your IO tree. So you have your triggered. So for this temperature sensor, it has 4 parameters. You have your triggered 1, triggered 2, temperature, and then it also has another channel to trigger. But as you can see, it gets automatically populated in your IO tree. So all of this is not available for any of our competitive sensors. So that's the premier integration that we have, and that makes it much more easy and seamless for any of the sensor. So we only have a couple of minutes left, but just wanted to go over some of the analytics platform we have. As I said, there's a lot of data, but Rockwell has 4 analytics platform, one for the devices. That's mostly used by the OEMs. There is one for the machines. Also, it's a machine builder. There is the FactoryTalk Team one, which is an app that you can use on your app in order to get alerts and messages. And then there's also the information solution. And basically, all of our sensors and all of our devices, I should say, the plan is to integrate all of them so that it works well with all of these analytics platforms. We're still, to be very honest, we're still trying. There's so many catalog numbers, right? And there's so many sensors that we're coming up with. But the idea is all of our sensors will be. And currently, most of our sensors are on of these analytic devices. And as you can see, the analytics, it gives you descriptive information, gives you the diagnostic information. Slowly, the analytics team will be able to predict when the failure is going to happen. And then when the standard allows us, we can also do the prescriptive maintenance as well. So that's it for me. There's a lot of, there's some more slides, but I can share the slides with you. There are some use cases that are inbuilt. Those use cases that, they are some of the success stories that we have, some of the applications that you can use IOLink as well as smart sensing system. But just want to leave you that, in a machine floor, there are so much of these data, and if you don't have your sensors smart enough to capture these data, it's all going down a waste. And next time when you think about smart sensing, just think about your smart devices that you have currently. You have your iPhone, right? So imagine ask these questions to you, right? How has a smart device changed your life? What it would be not having an iPhone or an Apple or an Android phone with you, and how it has basically helped your productivity. It's the same thing that's going to happen to the machine world. It's the same thing it's currently happening to the sensor world. So right now it's a time to make smart so that you can stay ahead of your competition. Thank you, and we have a couple of minutes. If you have questions, let me know.
Yeah, thanks, Rob. Well, web audience, feel free to chime in on the chat line, or could possibly even unmute your line. I just wanted to say, Rob that was there at the end was talking about applications and stuff. So we have of course, Rockwell has a ton of information online at their website. We have our own kind of Get Smart page with the smart sensing, and we'll send these links out as a follow-up to everyone. A lot of the same content that Rob was showing there. But those interactive, those application animations are all kind of posted at the bottom there. So that's a pretty useful. So we'll have everything kind of stored right there for you guys. So again, we'll share that out. So let's check for questions, and if not, we'll call it. Okay, no problem. So Rob, appreciate it.
Oh, thank you.
Very good presentation. Thank you for coming over today. Sorry for the webcam snafu there. We'll figure that one out next time. I get to see the top of my head, which was I'm sure very exciting for most people. Yes. That's that old game show, like You Don't Know Jack or whatever. That's kind of what it looked like. So we'll figure that out. So guinea pigs as always. All right, we'll call it. We'll end it here. If you got any questions, always follow up with myself, Bill, or your account manager. Once again, Rob, thank you very much.
Oh, thank you.